In lesson 14, putting it all together, we're going to work basically on using all of our methods and just kind of basically practicing the quadratic formula, some more factoring, completing the square, inverse operations, basically all the solving methods we learned in this unit. So solve the equation x squared plus 6x equals 16 using one of the three methods we developed in this unit. So they're not counting inverse operations as one. They're talking about completing the square, factoring, quadratic formula. And it says, why did you pick this? Well, we know no matter what method we are choosing, we always have to be equal to 0. So we'll subtract the 16 on both sides. All right. So x squared plus 6x minus 16. I'm going to do this through factoring. Okay. Now, I kind of look at this and know it's factorable. You might not. So you might not have chose factoring, and that's fine. So x squared, top left, negative 16, bottom right. So remember, we multiply the number out in front, the 1 by the negative 16. So multiplies to negative 16, adds to 6. And what does that? Well, we get 8x and negative 2x. So if we GCF this top row, we get an x. X times x is x squared. X times 8 is 8x. X times negative 2 is negative 2x. And 8 times negative 2 is negative 16. So our parentheses are x plus 8. X minus 2 equals 0. So there's the factoring part. And now we're going to set each parenthesis equal to 0. Set this way we can actually solve. All right, and then I get my answers to be negative 8 and positive 2. Okay, so again, you could have chose completing the square or the quadratic formula for this one. That's fine. But no matter which method you chose, you should have ended up with the same exact answers, negative 8 and 2. All right, and then to answer this question, why did I pick it? I thought it was the most efficient method to do this. All right, I think factoring takes probably the least amount of steps, so therefore I chose that one for something that's factorable. X squared minus 4x equals negative 2. So again, we know we have to be equal to 0. So x squared minus 4x plus 2 equals 0. Well, if I look at this, I know nothing's going to multiply to 2 and add to negative 4, so I know factoring is not an option. So I think I'm going to do completing the square here. So we'll complete the square. Okay. So I'm going to do middle number divided by 2. Actually, hold on. Sorry. I'll write out our parentheses and stuff first. So x squared minus 4x plus a line, and then plus 2 minus a line. So negative 4 divided by 2 is negative 2, and negative 2 squared is 4. So on each line goes a 4. All right. Now, if you remember, the parenthesis here always factors into the same exact parenthesis twice. So realistically, we are always going to write it as one parenthesis squared. And how do we know what that number is? Well, it's the number in the parentheses before we square it. So x minus 2 squared. And then on the outside, 2 minus 4 is negative 2. Okay. And now we're just going to solve. So we'll add 2 to both sides. We get x minus 2 squared equals 2. Square root, square root. Remember, when you square root a parenthesis, all you get is what is underneath. Equals 2 is not a perfect square. 2 does not split. So realistically, what we have to do is we really just have to remember to keep track of that plus minus out in front. Okay. So we will plus 2. Remember, you can't combine these. So we get x equals 2 plus or minus 2 square root 2. The number you add in front or you add over always goes out in front, plus minus in the middle, and then the final piece at the end. Okay. 2x squared minus 5x minus 12 equals 0. I definitely do not want to complete the square if I don't have to because of the 2 out in front and there's an odd number in the middle. So I always like to avoid completing the square. It might be factorable. I'm not sure, but to change up the methods a little bit, I'm going to do the quadratic formula, which again is on the reference sheet, but write it over here. So negative x equals negative b plus or minus big square root b squared minus 4ac all over 2a. So when I do that here, a is 2, b is -5, c is -12. All right, so a is always in front of x squared, b is always in front of x, and c is always the constant at the end. So x equals -b, so the negative of -5 is +5, big square root, -5 squared, minus 4 times 2 times -12, all over 2 times 2. So now we're going to be in our calculator here. So we are -5 squared. So -5 squared, make sure you're using parentheses, minus 4 times 2 times, I believe it was -12, and I just want to double check just to make sure. Enter. I get square root of 121. So 5 plus or minus square root 121 over, and 2 times 2 is 4. So now we're going to look at our radical. 121 is a perfect square. So by the way, that means that this was factorable. Square root of 121 is 11. Now, when you have no square roots left, don't worry about trying to like cross out the 5, the 11, and the 4. Just split it. So you get 5 plus 11 over 4, and you get 5 minus 11 over 4. So 5 plus 11 is 16. 16 over 4 gives you 4. And then 5 minus 11 is -6. And -6 over 4 gives you -3 over 2. So then your two answers are x equals 4 and x equals -3 over 2. So you've seen basically one of each style. I'm just going to do this last one here because this is just straight inverse operations. It's almost kind of like somebody completed the square already, and now we just have to do the solving piece. So we'd subtract our 37 on both sides. 5 parentheses x plus 2 squared equals 450. We'll divide both sides by 5. X plus 2 squared equals 90. Square root both sides. 90 is not perfect, but 90 does split into square root 9, square root 10. Comes back together to give us 3 square root 10. And because we are solving, we do have to make sure that we put our plus minus out in front. Minus 2 minus 2. X equals -2 plus or minus 3 radical 10. All right, again, that's simplest radical form. I just want to remind you real quick how you do rounding. So if we wanted to do rounding to the nearest tenth here, we'd have to do -2 plus 3 radical 10 and -2 minus 3 radical 10. So -2 plus 3 radical 10 to the nearest tenth would give us 7.5. And then if we did the same thing here, -2 minus 3 radical 10, we get -11.5. All right. So I just wanted to show you, you can keep your answers here in simplest radical form, but I just wanted to show you the rounding piece that goes along with it. So for the last one here, we just need to make sure that we are carefully setting it equal to 0 by making sure we put the like terms underneath each other. So 2x squared plus 6x plus 1 equals 0. I'm going to guess that this is probably not factorable. So therefore, I'm probably going to be either quadratic formula or completing the square. Now, with the number out in front, I don't know, completing the square is not my favorite. So I'd probably do quadratic formula here, but I do want to show you, again, a completing the square where you have to take a GCF out of the first two. But actually, no, I don't want to do that, because then that's going to leave me an odd number. It's going to be kind of terrible. So I'd much rather just do the quadratic formula. It's just, to me, the easiest out of all of them. So x equals -b, so -6 plus or minus big square root 6 squared minus 4 times 2 times 1 all over 2 times 2. So go to our calculator. 6 squared minus 4 times 2 times 1. that's going to be equal to 28. So x equals -6 plus or minus square root 28 over 4. Remember, you are not allowed to cross anything out at this moment. 28 is not perfect, but 28 does split. So we'll go off here on the side. It's square root 4 square root 7 gives us 2 square root 7. So we get -6 plus or minus 2 square root 7 over 4. And from here, now we can simplify. Everything divides by 2. So we get x equals -3 plus or minus 1 square root 7 or just square root 7 over 2. And there's our answer in simplest radical form. So you've seen examples of each type of problem. Now what I would like you to do is, number 2, is I'd like you to pause the video and I want you to try to solve each of these using whichever method you would deem to be most efficient. So if we look at the first one here, x squared minus 81 equals 0. To me, that is set up perfectly for factoring. And the reason is x squared is perfect, 81 is perfect, and there's a minus sign in between. So really we get our perfect squares factoring. The square root of x squared is x. The square root of 81 is 9. So we set up our two parentheses. They both start with x. They both end with 9. One gets a plus and one gets a minus. Now, if you don't remember that piece and you're maybe falling in love with the quadratic formula or something, you could plug in a 0x in the middle, and that would make your a 1, your b 0, and your c -81. So just in case you wanted to do the quadratic formula, it is doable. Just recognize that you're plugging in a 0 on the outside for b, okay? But if we finish solving here, we get x plus 9 equals 0 and x minus 9 equals 0. So if we solve for each, we get x equals 9 and we get x equals -9, okay? On the right-hand side, this looks like it's set up perfectly for inverse operations. So we'll add the 40, x plus 4 squared equals 40. Square root both sides. 40 is not perfect, but 40 does split. Square root 4 square root 10. We get x plus 4 equals plus or minus 2 square root 10. We'll subtract the 4 on both sides. X equals -4 plus or minus 2 square root 10. And again, that's simplest radical form. It doesn't say we have to round. So we're going to leave that as our answer. For the next one, now the problem with this one is that there are x's on both sides. You have the x locked in the parenthesis, and you have the 4x on the other side. So because, and if you look here, see how there was just the x in that parenthesis, there were no other x's in the problem? This is why this one isn't going to be inverse operations. The first thing we have to do is we actually have to multiply x plus 1 and x plus 1. We have to expand this one parenthesis that's being squared. So x squared, we get 1x, 1x, and 1. There are like terms. So now what we're going to do is we're going to replace this with its trinomial. So x squared plus 2x plus 1. And then we will be -7 equals 4x plus 1. Okay. So again, the reason we're doing that is because you can't do inverse operations when there's multiple x's in the problem. So now what we're going to do is I'm going to combine these two like terms. X squared plus 2x minus 6 equals 4x plus 1. I'm now going to set it equal to 0. So minus 4x minus 1 minus 4x minus 1. I get x squared minus 2x minus 7 equals 0. So now as I set this up, nothing multiplies to -7, nets to -2, so it's probably not going to be factorable. I've done a couple quadratic formulas, so what I think I'm going to do is I'm going to complete the square. All right, so I'll set up my parentheses here. I get x squared minus 2x plus a line minus 7 minus the line equals 0. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1, 101. So I know this right here is going to factor into x minus 1 squared. Negative 7 minus 1 gives me negative 8 equals 0. So now as I go to solve, it'll be plus 8, x minus 1 squared equals 8. Oops, square root both sides. 8 is not perfect, but 8 does split. Square root 4, square root 2. We get x minus 1 equals plus or minus 2 square root 2. I'll add the 1 to the other side, and I get 1 plus or minus 2 square root 2. So this is probably the hardest of all of them because it involves all this work that's in the black pen first, just to be able to get it set up equal to 0 so that we can use one of our methods. X squared minus 3x plus 16 equals 5x plus 15. All right, again, can't do anything until it is set equal to 0. X squared minus 8x plus 1 equals 0. So good chance not factorable because nothing multiplies to 1 and adds to negative 8. Because I just did completing the square, I'm going to do the quadratic formula here. So x equals negative b, so a positive 8 plus or minus big square root negative 8 squared minus 4 times 1 all over 2 times 1. So calculator, negative 8 squared minus 4 times 1, 60. So x equals 8 plus or minus square root 60 over 2. 2 times 1 is 2. 60 is not perfect, however 60 does split. Square root 4, square root 15 comes back together to give us 2 square root 15. So x equals 8 plus or minus 2 square root 15 over 2. These all simplify. They can all be divided by 2. And when we do that, we get x equals 4 plus or minus square root 15. And we do not have to write over 1. So there is our final answer. And for our last ones here, 2x squared plus 3x minus 1 equals 0. Now the fact that the equal 0 is over on the left is irrelevant. You could very easily just put that on the right-hand side and it would still work. So this one doesn't appear to be factorable. So I'm going to stick again, I don't like the odd number in the middle for completing the square. So I'm going to stick with the quadratic formula. So a is 2, b is 3, c is negative 1. X equals negative b, so negative 3 plus or minus 3 squared minus 4 times 2 times negative 1 over 2 times 2. So we'll go to our calculator here. We are 3 squared minus 4 times 2 times negative 1 gives me 17. X equals negative 3 plus or minus square root 17 over 4. 17 is not perfect. 17 does not simplify. Therefore, my final answer is left right there. So when you get square roots that don't simplify and aren't perfect, usually you just end up stopping your answer right there. 9x squared minus 15x minus 24 equals 0. I want to start by trying to factor this just because I see that there's a GCF for all of them. So I get 3, so that would give me 3x squared minus 5x minus 8 equals 0. I do want to try to factor this just because we haven't done much factoring in this piece. So as we go to factor and solve, this 3, because it doesn't have an x, is fairly useless to us. So I'm just going to build my boxes off of what's here inside. So 3x squared and negative 8. 3 times negative 8 is negative 24, and they have to add to negative 5. So the numbers that do that are negative 8x and a 3x. So if we go to GCF, the top row here, all we can take out is an x. Well, x times 3x is 3x squared. X times negative 8 is negative 8x. 3x times 1 is 3x. And 1 times negative 8 is negative 8. So we have 3 still out in front as our GCF. And then our first parenthesis is 3x minus 8. And our second parenthesis is x plus 1. So now as we go to set them equal to 0, remember you do not set that 3 on the outside equal to 0 because it doesn't have a variable. So it's just going to end up being 3 equals 0, which we know doesn't make any sense, so we just leave it out. As we go to solve here, add 8, 3x equals 8. We'll divide by 3, and x is 8/3. And then minus 1, and x is negative 1. So factoring might not have been your chosen method for that one, but your answer still should have been 8/3 and negative 1.